In this video, we're going to look at some examples of calculations involving energy and nutrition. So first, a note on units. In chemistry, the most commonly used units for energy are the joule and the calorie. And just like we have pounds and kilograms, so we can convert back and forth between them, we have a way to convert back and forth between calories and joules. Now, one important thing to note, in the field of nutrition, the energy content of food is usually measured in a calorie, but it's different than the calorie that we use in chemistry. And to differentiate between the two, when we're talking about the unit that a chemist would typically use, we use a lowercase c, and then for nutrition, they use an uppercase c. And it turns out that a capital C calorie is actually a kilocalorie with a lowercase c, right? So what I'm saying is a calorie with a capital C is equal to 1,000 calories with a lowercase c. So a calorie with a capital C is actually a kilocalorie that a chemist would be familiar with. Okay, another thing we need to know is that most of the energy that we get from food comes from carbohydrates, fats, and proteins. And regardless of where these carbohydrates, fats, and proteins are coming from, they tend to give the same amount of energy. So a gram of carbohydrate typically gives 4 kilocalories worth of energy. A gram of fat is worth 9 kilocalories, and a gram of protein is worth 4 kilocalories. And so they have the amounts in this table in both kilocalories and kilojoules. So depending on what the problem asks, we might use one of the columns of the table or the other. So here's a typical example. So we want to know the total number of kilojoules in a serving of popcorn that contains 8 grams of fat, 13 grams of carbohydrates, and 2 grams of protein. So we can use these values in the table like conversion factors, and we can convert the grams of each one of these types of molecules into the energy. And because in this problem, we're specifically asked for kilojoules, we're going to be sure that we use the kilojoules column of the table. So what we want to do is, first I'll start with carbohydrates because that's first in the table. So I have 13 grams of carbohydrates. So if I do my carbs, I'll take my 13 grams of carbohydrates, and then from the table, I know that every 1 gram of carbohydrate is going to give me 17 kilojoules worth of energy. Right, so my grams are going to cancel, and when I do 13 times 17, I get 221 kilojoules. All right, I can do the same thing for the fats. So in this case, I have 8 grams of fat. And 1 gram of fat will give me 38 kilojoules. So that comes out to be 304 kilojoules from the fat. And I'll do the same thing for the protein. Right, now I've got 2 grams of protein. Again, so 1 gram of protein, 17 kilojoules. Okay, so now I know how much energy I get from the carbohydrates, the fat, and the protein. So all I need to do is add these up, and I'll get the total amount of energy from this serving of popcorn. And when I do that, I get 559 kilojoules. Okay, I've got one more example on the next slide. Okay, this is a similar problem, only now instead of calculating in energy, I want to know how many grams of protein are in 1 cup of soup that has a total of 110 calories, and we know that there are 9 grams of carbohydrate and 6 grams of fat. So remember from our earlier discussion, a calorie with a capital C is actually the same thing as a kilocalorie. So we're going to use this column of our table for this problem. Right? And so I know how much carbohydrate and fat I have. So I can do just like we did on the last slide and use these values to figure out how much energy I'd get from the carbohydrates and fat. Right? And so then I can subtract that from the total energy, and whatever energy is left must have come from the protein, and then I can use that I know that 1 gram of protein will give me 4 kilocalories, and that'll allow me to figure out how much protein I have. All right, so the first step is to convert my mass of carbohydrates and fat into energy. So I'll put a C for carbs. So I'll take my 9 grams of carbohydrates, and now 1 gram of carbohydrate will give me 4 kilocalories. I'll do the same thing with the fat. So now I have 6 grams of fat. So 1 gram of fat will give me 9 kilocalories. For a total of 54 kilocalories. So between the carbohydrates and fat, 36 plus 54 gives me 90 kcals. Right? And so in total, this cup of soup had 110 kilocalories. Right? 90 of them came from the carbohydrates and fat, so the difference must be the proteins. Right? So to figure out my proteins, I'll take the 110 total kilocalories minus the 90 kilocalories from the carbohydrates and fat, and so that leaves 20 kilocalories for the protein. All right? And remember, with our conversion factors, we can go in both directions, right? So on the last one, and in the earlier part of this problem, for the proteins, we would have used that 4 kilocalories in 1 gram, but we know we can always do the opposite too. So I could do the 1 gram on top and the 4 kilocalories from the protein on the bottom. And so that's what we want to use on this one, right? Because for my protein, I have 20 kilocalories. I want the kilocalories to go away and get it in grams, so I'll put my 4 kilocalories on the bottom, the 1 gram on top. So that means I have 5 grams of protein, and that is the answer that they want.